Hello, our lesson today is on the the LO of how do I successfully write numbers in standard form. Standard form is a way or is a tool that mathematicians and scientists use to be able to handle very big or very small numbers. So it's really important that we understand exactly how it works. So to begin with our understanding today, I would just like you to work your way through the warm-up. It's all about powers of 10, which is exactly what um, standard form is all about. So pause the lesson, work your way through it, come back to the lesson when you're ready for the answers. Okay, so 5 times 100 is 500, 3.5 times 1,000, 3,500, 8.75 times 10 is 87.5, 9.03 times 100,000 is 903,000. 1 million in figures is a 1 followed by 6 zeros, because a million is 1,000 thousands. So you've got the first 3 thousands the first 3 zeros are for the thousand, the second 3 zeros get you up to a million. 1 billion, which is, as the sheet says, 1,000 million, has a 1 followed by 9 zeros. Again, they're in groups of 3. Basically, as a rule, every group of 3 zeros has a new name, so it's a handy way of remembering it. Work out the value of 10 cubed. So 10 cubed is 10 times 10 times 10. 10 times 10 is 100. 10 times 100 is 1,000. So 10 cubed is 1,000. So use this to work out the value of 13.4 times 10 cubed. Well, it's the same as 13.4 times 1,000, which will be 13,400. If you need to do any checks now, please do so. When you've finished, please rejoin the lesson. Okay, so now we're going to actually look at what standard form looks like. A number in standard form has got two parts. The first part, which is always a number between 1 and 10, so it can't start 0 point, it can't start 10 point. It will be between 1.0 and 9.9, followed by a multiply sign and a number or a power of 10. So it always looks the same. It always has a decimal number at the start, which is a number only has a number in the ones column, and then a decimal places after that, and a power of 10 written after it. So let's have a quick look at how we answer that. Write each number as an ordinary number. So let me just get my writing pad out and we'll start. So we'll do the first one, even though it's already done. Let me just hold this a bit clearer so everyone can see. So 3 times 10 squared is the same as 3 times 100, which is 300. Easy enough. 5 times 10 to the 6th is the same as 5 times a million. Remember, we've got 6 zeros. The power of 10, the power there tells you how many zeros that there is in the number. So obviously 5 times a million is 5 million. 7 times 10 to the 4th is the same as 7 times 10,000, which will be 70,000. And lastly, 9 times 10 to the 11th is 9 times a 1 followed by 11 noughts. That is 100 billion, which is going to be, I'm going to have to write that down here, 900 billion. And this is the reason, one of the reasons why we use standard form, because this number is much easier to write than this number. As you can see, it would have literally filled my page. So numbers in standard form are much shorter and easier to understand. So the next example that they've got there is 4,000 in standard form. So the way we do that is I'm going to write that. The first thing I'm going to do is I'm going to say, let me see, 4,000 in standard form. Now obviously my decimal number is going to, or my first number is going to be 4. What do I multiply 4 by to make 4,000? Obviously it's 4 times 1,000, and 1,000 as a power of 10 is 10 to the third. So that's writing a number in standard form. It's quite simple. Just as long as you're familiar with the powers of 10, you'll be absolutely fine. Remember, when we're writing in standard form, we don't have to remember the words that go with the numbers. It's all just powers of 10. So it is as easy as it can be. Right. If you've got that, if you need to carry on to write that down, please pause the lesson. Otherwise, carry on and try and catch up when you're done. So, this next example that we've been given is write 45,600 in standard form. We must write all numbers in standard form with only a number in the ones column. It can't be any bigger than in the ones column. We don't have any numbers in the tens. We don't have any numbers in anything bigger. So the way we write that number is going to be 4.56. What number do I multiply 4.56 by to make it into 45,600? Well, I've moved the decimal, or the numbers have effectively moved over 4 places to the right to get to 4.56. So I must multiply it by a number 10 to the power raised to the power 4. If it's got to move 4 places to the right, we need to multiply it by 10 to the 4th. So my number, as I said there, would be 4.56 times 10 to the 4th. When we look at the example we've got here, so we've got 67,500. The first bit I can do is I can turn that into a decimal number with one number in the units column and write 6.75 times 10. I can write all that down without even thinking about anything else. Now, what power of 10 do I need to multiply this number by? Well, my number, or to get to here, to get back to this number, my numbers have to move 1, 2, 3, 4 places. So that will also be 6.75 times 10 to the 4th. So it all depends on how many places the numbers have to move. Okay, so here's another collection to write in standard form. If you like, pause the tape now and have a go yourself. I'm going to be going through them in a second anyway, but if you want to just pause the tape and have a go, that's fine. Otherwise, I'll just pause briefly for a second to give you a chance to get the tape or the lesson organised, and then we'll carry on. Okay, so 70,000. Good place to start. My decimal number don't need to be a decimal number. I'm just going to say that's 7. And what have I got to multiply 7 by to turn it into 70,000? I've got to multiply it by 10,000, which is 10 to the 4th. $72,000. My decimal number this time is going to be a decimal number. It's going to be 7.2 because that's all the numbers I have, and the first number has to be in the ones column. What have I got to multiply that by to make? What have I got to multiply 7.2 by to make 72,000? I've got to multiply that by 10,000, and as we know, 10,000 is 10 to the 4th. And lastly, we've got 720,000. Once again, the decimal part of my number is going to be 7.2 multiplied by 10. But what have I got to multiply 7.2 by to turn it into 720,000? Well, it's 100,000. So 100,000 is a 1 followed by 5 noughts. So this is going to be 7.2 times 10 to the 5th. So in each case, the number or the power is how many places we have to move the number to get it back to our original number. Okay, if you need to carry on writing for a minute, pause the lesson, otherwise just carry on coming up with me now. Okay, so it's your turn. We've got some numbers for you to have a go at this time. So pause the lesson, have a go at these three, and when you're ready, come back to me for the answers. Okay, so my answers: 60,000, 6 times 10 to the 4th. 63,000, 6.3 times 10 to the 4th. 630,000, 6.3 again, times 10 to the 5th. Hope we all got that correct. Otherwise, if not, just pause the tape for a moment or replay it if you're a little bit uncertain, and then return back to the lesson when you're ready. So we've got a few more for you to do now. 1, 2, 3, 4, 5, 6, 7, 14 questions. There is no rounding to do, so don't worry about the fact that some of these numbers are going to look quite long even after you've written them with one number before the decimal point. Don't worry about that, just write it down and do what you need to do. So pause the lesson now, return back when you're ready to carry on. Okay, so here are our answers. 200 changes to 2 times 10 squared, or 2 to the power, 10 to the power 2. 2,000 changes to 2 times 10 to the 3rd. 20,000, 2 times 10 to the 4th. 29,000, 2.9 times 10 to the 4th. 29,400, 2.94 times 10 to the 4th. 29,470, 2.947 times 10 to the fourth. 294,700, 2.947 times 10 to the fifth. 994,700, 9.947 times 10 to the fifth. 1,994,700, 1.9947 times 10 to the sixth. 19,947, 1.9947 times 10 to the fourth. 10,000, 1 times 10 to the fourth. 10,100, 10.01 times 10 to the fourth. 10,010, 1.001 times 10 to the fourth. And 1 billion 1 million 1.001 times 10 to the ninth. So at the moment we're not concerning ourselves with rounding. It's just everything. You write down everything that isn't a zero, really. I hope that all made sense. I hope you got all of those correct. If you need to write down some corrections, please do so now, and then return back to the lesson when you're ready. Okay, so nice and simple this next one. We're going the opposite way now. Oops, sorry, I'm going to bring that back. I didn't mean to hit that button. There. Right. 3.1 times 10 to the 6th is a normal number. Okay, so the one thing that I know is I'm going to have a 3 and a 1 in it. I'm not putting any decimal points down now. I'm multiplying it by 10 to the 6th. That means I need 6 places of decimals, or 6. I need zeros to get this up to 7 numbers. So I need 5 zeros. So 3.1 times a million is 3,100,000. So all we need to do is just write down the number in front and then just write it so that we would have the number. So effectively we need the number of the powers plus the unit number to make it up. So in this case, because I've multiplied it by 6, I need a 3 and then 6 numbers including the 1, so I need 5 zeros. Okay, can you have a go at that one for me, please? Pause the lesson and then come back when you're ready with the answer. Okay, so we're going to do 3.2 times 10 to the 7th. So we're going to start off with a 3 and a 2. Now with the 2, I need to have 7 numbers. So I've got 1, so I need another 6 zeros. So 3.2 times 10 to the 7th gives me 32 million. 10 to the 7th is 10 million. 3.2 times 10 million is 32 million. Okay, if you need to write down a correction, pause the lesson and do so. Otherwise, we shall carry on. Okay, here's some for you to have a go at now. So you've got 3.2 times 10 to the 3 all the way down to 9.003378 times 10 to the 11th. Okay, pause the lesson, work out your answers, and return back to me when you're ready. Okay, here we have the answers. So 3.2 times 10 to the third, 3,200. 3.3 times 10 to the third, 3,300. 3.37 times 10 to the third, 3,370. 3.37 times 10 to the sixth, 3,370,000. 3.378 times 10 to the sixth, 3,378,000. 1.3378 times 10 to the sixth, 1,337,800. 1.3378 times 10 to the ninth, 13,378,000. Sorry, my mistake. 1,337,800,000. Sorry, 13,378,000. Sorry, 1,337,800,000. Sorry about that, I just couldn't read the zeros. And the next one is 1,033,780,000. 9 times 10 to the 11th is 900 billion. 9.003378 times 10 to the 11th is 900,337,800. There's some numbers in there. What I suggest you do is you pause the lesson now and just check that you've written down the right number of zeros in each case. Once you've done that, please return to the lesson and we'll carry on. Okay, so here's some numbers in standard form. Write each of these numbers in standard form, then convert the numbers at the bottom into ordinary numbers. So it's basically what we've been doing so far, but this gives you a little bit more time to practice. So pause the lesson now and return when you've got your answers. Okay, so here's the answers. What I'm going to do this time is I'm just going to pause and let you write down the correct or check the answers. Make certain you've got the correct number of zeros. I mean, obviously the first one is relatively simple to do. 5 times 10 to the power 2, 3 times 10 to the 5th, 9 times 10 to the 9th, and 7 times 10 to the 6th. The others, please take your time and work your way through by yourselves. When you're ready, restart the lesson. Okay, for these next questions, what we're doing now is we have the normal number, we have the numbers written in the normal type, we have numbers written in standard form. You just have to decide which one is which. You can either draw that grid and line across, or just write down which one is the same as that. So, for example, if you think that 79,000 is the same as 7.9 times 10 to the 8th, that's what you write next to it. Then underneath again, we have numbers in standard form, or to write numbers in standard form. Be careful with questioning, with question H. And so pause the lesson now, work out your answers. So, on our list, A is the same as D, B is the same sorry, yeah, B is the same as B, C is the same as A, D is the same as H, E is the same as G, F is the same as F, G is the same as E, and H is the same as C. If you've just written them across from each other, you may now need to pause the tape again at the end and check. Then underneath we have the numbers in standard form. So A is 4.5 times 10 to the fifth, B is 3.2 times 10 to the fourth, C is 1.5 times 10 to the fifth, D is 7.25 times 10 to the sixth, E is 6.291 times 10 to the sixth, F is 1.5 times 10 to the sixth, G is 7.03 times 10 to the eighth, and H is 7.6 times 10 to the 10th. Okay. If you need to write any corrections, please do so now, and then rejoin the lesson. Okay, two more questions for you to have a go at. One about looking at the calculated display, the other looking at numbers and saying, right, okay, they're not written properly, they're not written in standard form, what will we have to do to change them? And there is a hint. If you look at the hint, it says 33.4 times 10 to the 3. We know that's not right. It's not right because numbers in standard form must be between 1 and 10. They can't be as much as 10. There can be no number in the tens column. So we need to rewrite that as 3.34. Now, if I've multiplied it by 10 to the third to get it to 33.4, or if I have to multiply it by 10 to the third to get it back to its original number, if I multiply, so I'm multiplying 33 by 10 to the third, I have to multiply 3.34 by a number that's 10 times bigger, which is why there it's written as 10 times 10 to the third. And effectively, when you're multiplying 10 by 10 to the third, you're getting 10 to the fourth. So if you move the decimal place over, if you move the numbers over to the right one place, you add 1 to the power. If you move the numbers to the left one place, you subtract 1 from the power. So have a go at those, please. You may wish to replay the lesson there and go over that point again, but give those a go. So 4.4368 times 10 to the 10th is 44,368,000,000. 33.4 times 10 to the third becomes 3.34 times 10 to the fourth. 27 times 10 to the fifth becomes 2.7 times 10 to the sixth. 42 times 10 to the second, or 10 squared, becomes 4.2 times 10 to the third. 0.4 times 10 to the third, now this is going the other way from the ones we've just been doing, becomes 4 times 10 squared. So if we're making the decimal number smaller, so we're going from 33.4 to 3.34, we add 1 to the power. If we're making the number bigger, so we're going from 0.4 to 4, we subtract 1 from the power. Then 0.87 times 10 to the sixth becomes 8.7 times 10 to the fifth, and 50.5 times 10 to the fourth becomes 5.05 times 10 to the fifth. This is a really, really important skill, and you need to understand it. So please do go over that again if you don't think you fully understand it or you're not 100% certain. Other than that, just carry on. Okay, so here we go. This is the sort of thing that standard form is actually used for. Not so much in the solar system, but astrophysicists, people use it. Astrophysicists use it for their calculations. It's for dealing with very, very big numbers. And here's a perfect example of very, very big numbers. It's the distance from the sun, the average distance from the sun of the various planets in our solar system. So the first thing you have to do is rewrite those distances as standard form, and then a trillion. So a trillion is 10 to the 12th. Write it down both as an ordinary number and in standard form. So I'd like you to pause the lesson now, please, and answer these questions, then return after you've done them. So, planets, we have Mercury, 5.8 times 10 to the 7th, Venus, 10.8 times 10 to the 8th, Earth, 10.08 times 10 to the 8th, Earth, 1.5 times 10 to the 8th, so not really very far away from Venus, Mars, 2.28 times 10 to the 8th, Jupiter, 7.78 times 10 to the 8th, Saturn, 1.433 times 10 to the 9th, and Uranus, 2.781 times 10 to the 9th, and Neptune, which is a huge distance away, nearly twice the distance, 4.0503 times 10 to the 9th. That's nearly twice as far as Uranus. Okay, so now a trillion. Let me just get back onto the paper. As an ordinary number, it's going to be 1 followed by 12 zeros. So we're going to group them in threes. So that's what a trillion looks like. And finally, in standard form, it's 1 times 10 to the 12th. I mean, we're already told it's 10 to the 12th, so it's just one lot of 10 to the 12th. So that's the number in normal form, ordinary form. That's the number in standard form. By now you should be seeing why it's much, much easier to do things in standard form. Okay, if you need to write any corrections, pause the video, pause the lesson rather. Other than that, and then rejoin when you've done. Other than that, we'll carry on into our next question. Well, we've got 12 already written again, so we won't bother with that one. Table shows the meaning of prefixes for large numbers. Write the following measurements in standard form. Okay, so these are the sort of things that you may well have come across in terms of computers, because quite often when we start looking at bytes of data, we tend to use these words. I mean, I can remember when kilobytes were considered to be huge in terms of computing. So yeah, it's very interesting to see the numbers that we've got now. So once you've written down those words and then them in standard form, have a go at those conversions, and then put down greater than or less than in the boxes. So you've got to decide whether each number is, which is the biggest one of each pair of those numbers. Okay, so when you're ready, pause the lesson and we will then return when you've got your answers. So obviously 12 we've already done. Then a terabyte is 10 to the 12th, so 8 times 10 to the 12th. 4.6 millimeters in meters is 4.6 times 10 to the 6th. 17.7 gigaliters in liters. Now there's a measurement you don't see every day. 1.77 times 10 to the 10th, and 9.5 kilograms in grams is 9.5 times 10 squared. So I hope you got all those correct, and then there are the signs on the bottom. So if you need to pause the lesson to get all your corrections written down, that's fine. Otherwise, carry on with our next slide. Okay, these are the sort of things that you could actually see in an exam. So we've got a set of numbers in standard form to order. So start with the largest number, and then we've got a number to write in standard form and a number in standard form to write as an ordinary number. These are all very, very common. It's a very common style of exam question. So when you're ready, pause the lesson and work your way through those, please, then restart. Okay, the way I would tend to do this first one is the first thing I would put them in order of is the power of 10. So whichever number has got the largest power of 10, regardless of anything else, is the biggest. So that's going to be 3.2 times 10 to the 9th. Then you've got an 8, 3.2 times 10 to the 8th. Then you've got a 5, 3.2 times 10 to the 5. Then you've got a 4, 3.2 times 10 to the 4th. And then you've got one left, 320, which would obviously be 3.2 times 10 to the 2. So in a lot of ways, ordering standard form can be really, really easy because that number tells you it. 705 million. Sorry, 705 billion in standard form. 7.05 times 10 to the 8th. And 3.45 times 10 to the 7th as an ordinary number becomes 34,500,000. Okay, so if you need to do any corrections, please do so now. That gets us to the end of this lesson. Our next lesson, we are going to look at writing small numbers, which is very similar to what we've already done. The process is very similar, but the numbers are going to be small. So we've looked at writing large numbers. We're now next going to look at writing small numbers. Okay, thank you very much for your time. I hope you've learned this. Please don't be afraid to run over this again if you think it will help. Thank you. Bye.